Hey physicists, I'd like to go through some of these position versus time graph problems and see what they look like as far as the motion they describe and the velocity. The first one is pretty much given to you. You can see that our position is not changing during that first section. We're staying at the same position, 20 meters for the first second. Then we move forward or further away up until 3 seconds, standing still again, and then we move backward or to a lesser position, if we call it that, till 6 seconds. And that little summary is right here. We want to put together the velocity graph. So I've created a velocity versus time graph. Velocity on the vertical axis, time on the horizontal axis. I've tried lining it up with the graph above. So we're at 1, 2, 3, 4, 5, 6 seconds, at 1, 2, 3, 4, 5, and 6 seconds. Initially, we can see we're at 0 velocity. I can indicate that with a line right. For the next 2 seconds, I can see I'm at a constant positive velocity right along here. I see again I'm at 0 velocity for the next second and a half. In this last portion here, I'm actually at a negative velocity. And I could actually give these values. Let's take a look at the velocity here. I went 40 meters in 2 seconds. Notice the change in the position divided by the change in time. I went 40 meters in 2 seconds, so I'm at 20 meters per second. Got my units listed here. Okay, now let's take a look over here. I'm going backward again, so I know it's kind of a negative velocity. I go 40 meters, so that's going to be negative 40 meters. And how long did it take me? 1.5 seconds. So in this part, I'm at about minus 27 meters per second. So that would end up being about minus 27 here. Let's take a look at this next graph. Again, it's position on this axis, time along this axis. We can see the object is starting at the origin and continues to move forward, always moving forward. But remember, the slope of this tells us how quickly our position is changing. So if I want to tell the story, I see that the object starts at rest, it's almost horizontal slope there, then moves forward. We see it's an increasing position with time, with an increasing velocity. Slope gets steeper. Let's go ahead and make the velocity versus time graph as well. Velocity on this axis, time on this axis. Velocity is measured in meters per second. That also tells us that the slope of this is meters over seconds. Let's take a look here. At the beginning, we have a slope of 0. It's almost a horizontal line. So I'll go ahead and mark that in there. Up here, we have a positive slope. In fact, it's more positive here than any other place along there. So I'll mark it up here. And I can see it's increasing at a constant rate. So I've got my line there. If I wanted to get an approximate value, I can see between 4 and 5 seconds it went forward 20 meters. That's from 30 to 50 in 1 second. So it looks like we finish up around 20 meters per second. So just a quick review here, that at the origin, or at 0 time, we were at rest, and we started moving forward with increasing speed. We see that here. As time goes along, the value of velocity continues to increase. The third graph here, we don't have any numbers here, so we won't be able to give values, but we can see that as time goes on, that the object is always moving forward. Okay. But we see that in this area, it's very steep, which is it's going to be a high positive value, and by the time we get over here, it's still positive, but it's a lower value. So let's go ahead and write a story for this. So I have my note here. The object starts off moving fast. We can see that here. Always moving forward and slows with time, but it is still moving forward. Let's go ahead and make the velocity versus time graph for this one. Now, except for position and time, I don't have any units associated with this, so I know my final slope will be in position over time, but I don't know what the units are, so I'm just describing it as velocity, and along this axis, again, we'll have time. Let's take a look. Initially, we have a high positive slope, which will mean I have a positive velocity. And toward the end of our time here, we still have a positive velocity, so I still know it's on the positive side. But it's much less than when it started off, maybe here. and we know it's constantly changing, so I'll go ahead and draw in my line here. Sorry about that. There we go. And notice how the velocity graph matches our writing here, that it starts off fast, okay, and slows with time. Let's look at our fourth example. This one we have position. In this case we do have units over here, and our time in seconds, just fractions of a second. See that we have a straight line along here, indicating, let's see, that we're moving at constant velocity. Constant velocity. And the position is increasing, so we know it's constant velocity forward. Or generally that's going to be called the plus direction. I'll go ahead and create the velocity versus time graph. This one we can see our velocity is going to be in centimeters per second. So I've labeled my axis velocity in centimeters per second. 0 is the center position, positive velocity up, negative velocity down, and this of course is measured time in seconds, the same values that we have up above. Let's see if we can come up with a value for this. We know that once we figure out the slope for any part of the line, we'll know the slope for the entire line, and the slope of the position versus time graph is velocity. Well, I'm looking for velocity, and that's equal to the distance over time. It's going to be easiest just take the endpoints here and here. Velocity 2 minus velocity 1. Sorry, let me change that just a bit. It should be our final position minus our initial position over our time. In this case, we're going to 80 centimeters. We started at 0 centimeters, and our change of time was 0.4 seconds. So I have 200 centimeters per second. Let's go ahead and put it on the velocity versus time graph. So there I've got it showing constant velocity. It does not change, and the value we remember was 200 centimeters per second. This one's a little more complicated. We can see again we have a position versus time. We also see that our object, as time goes along, either stands still or continues to move forward. So we know that. Let's break this down. In this section here, it's not moving at all. The position is staying the same. During this next section, I can see it's moving, but it has this curve, so I know it's speeding up. I'm going from something that has a 0 slope down here up to something that has a high positive slope. And then in this final section, I can see it's moving at a constant velocity because the line is straight. As time goes along, it changes its position at a constant rate. Let's see if we can go ahead and graph this, or first tell the story. So I've told this story. The object is at rest for 2 seconds, speeds up moving forward for 2 seconds, and then travels at a slower constant velocity for those final 2 seconds. Let's go ahead and make the velocity versus time graph. So for 2 seconds I'm standing still. I'll draw that in here. Then starting at rest, I increase my velocity with time. And then for the final 2 seconds, traveling at a constant velocity. I tried using the same colors I highlighted these sections up with. Well, we know that this is 0 velocity. This is going to be a little tricky to figure out. We know that it starts at 0 and ends at some high positive value. Let's take a look at this last section. I go from 4 to 5, so I know I've moved 1 meter forward, and it's taken me 2 seconds. 1 meter divided by 2 seconds would be 0.5 meters per second. So we know that's at 0.5 meters per second. Let's look briefly at this last one. We can see we can divide this up really into 2 sections. There's the flat section here, and then there's the curved section all the way out here. So a quick story would be we're at rest, then somehow we're going fast, and then we're slowing down, but always going forward. So as I've gotten written here, we're at rest for about half a second, move forward quickly, slow down till we're almost stopped. Let's go ahead and put it down here. Okay, so we're initially at something close to 0 velocity. Then we have a high positive value, and by the end of this we're just about at 0, so we can end up going along here, going down to here, and just put a little line there to connect the two. So again, just kind of a quick review as the mathematicians would look at this. We have zero slope along here, so we have a zero value here. We have a more positive slope right in here, so we have a more positive velocity value. As we go out, we see that our velocity is getting less and less, or our slope is getting less and less, till we're just about at a zero slope here. Zero slope here, in the middle, less positive slope, less velocity value.